So in part B, we're given that a triangle ABC has 3 vertices, as I listed here, and vector u is the vector from A to B, and vector v is the vector from A to C. We're given that u dot v is 3, and the triangle ABC is root 6, the area of the triangle. In part 1, we need to find the magnitude of u cross v. So we know this: if u and v are adjacent sides of a triangle, the magnitude of their cross product will be double the area of a triangle. We know the area of the triangle is root 6, so this will be 2 root 6. In part 2, we need to find the magnitude of u. Now this will be a little bit harder, so we need to solve some systems of equations here in the next part as well. So what we need to do, firstly, is we can define what the vector v is, because we know the coordinates of A and C. So it's from A to C, so we do the coordinates of C minus the coordinates of A. So this will be 3 minus 0 is 3, 2 minus 1 is 1, 1 minus 2 is minus 1, like this. And with this, we can find the magnitude of v, right? So we just have the vector v. We find the magnitude, we take the sum of the squares of the coordinates, and we take the square root of that. So that will be root of 9 plus 1 plus 1. Then it will be root 11, like this. And we can write now the definition of the dot product and the cross product. So u dot v is equal to the magnitude of u times the magnitude of v times the cosine of the angle in between. This was 3. And we can also write down that u cross v, the magnitude, will be equal to u times the magnitude of v times the sine of the angle in between. This will be 2 root 6. So we can rearrange both equations for the magnitude of u. So the magnitude of u will be 3 over the magnitude of v cosine theta here. And then the other one, the magnitude of u will be 2 root 6 over v times the sine of the angle in between. And obviously the magnitude of u is the same, as it's just a vector. So we can set these two equal to each other. And if we do that, we know the magnitude of v, and from that we can find that the angle in between two vectors. So from this we will find that theta is 1.021. We can simply plug it into NSolve and it will give us this value. And so if we plug this theta back into here, we know the magnitude of v, so we can find the magnitude of u is 1.73. So this is what part 2 was asking of us, the magnitude of u. And then in part 3, we need to find the values of p and q, or possibly the pairs of p and q. So firstly, let's write down what this u vector is. So this is from A to B. So we need to do the coordinates of B minus the coordinates of A. So p minus 0 is p, q minus 1, and 3 minus 2 is 1. All right, and then we know that the magnitude of this is 1.73, but we can also write down the magnitude in terms of the coordinates. So we have p squared plus q minus 1 squared plus 1, like this. All right, so what we can also do now is write down the dot product of u and v. So we can just take the dot product of these two vectors over here. So that will be 3p plus q minus 1 minus 1. And we know that this is equal to 3, as we've been told at the very start that the dot product of the two vectors is 3. So this will tell us that 3 is equal to 3p plus q minus 2. So we can actually say that this is 5 is equal to 3p plus q. All right, and then from this we can rearrange for one of the variables. So q is 5 minus 3p. All right, and now what we can do is plug this into here. So we'll have a square root. So we'll have 1.73 being equal to p squared plus 5 minus 3p, but that'll just be 4. So 4 minus 3p squared plus 1. And we can use our GDC again with NSolve. We just input this, we solve for p. We find that p can either be 1 or p can be equal to 1.4. Again, we can kind of expect there to be two results, as this is a quadratic expression here. And then we can plug these values in back here so we can find the values of the corresponding Q's. So here Q will be 2 and here Q will be 0.8.